clouds are an approach to help manage that complexity. And two words here. So open, IDC, I think most of you are probably familiar with, very quantitative-oriented market research firm. And they did a study, concluded I think in August. Gary Chen actually spoke at the Linux Foundation's Cloud Open event. And he said that open cloud is key to 72% of customers that they talk to. And he said that actually when you look at lock-in concerns, of course we've been talking lock-in forever in the computer industry, but he actually observed that lock-in concerns around cloud are magnified. And I think you've heard some of the reasons for that today, because you can end up not only being locked into a vendor's technology, but both your applications and your data can actually be locked into a service provider who's not even under your physical control. Gartner, looking at another, one of the largest market research IT analyst firms, had made a comment: design private cloud deployments with interoperability and future hybrid in mind. One point I'll mention here is, as we talk to customers and also with what the analysts say, hybrid, in other words, a combination of on-premise or dedicated resources and public cloud providers, is in relatively early days today. It's not something that a huge number of people are doing. But what all these analyst firms are observing, and what frankly the customers that we're building clouds with want, is to preserve that as an option, as a use case, because the folks that we're building essentially private clouds for today, nearly all of them imagine as part of that infrastructure deploying the public cloud, such as Amazon, in the future. So let's sort of unpack these words a little bit. And I'm going to go through some of the aspects of open source and other forms of openness. A lot of people talk about open these days. Has anybody heard, maybe some cloud provider out there mention the word open in context of their products? One or two, maybe? And the fact is, there are certainly many providers who are, whether it's technology vendors or cloud providers, who are genuinely open along a number of these axes, but there are certainly others who are, I think, fairly narrowly defining what it means to be open. So, open source is probably the most obvious aspect here. I think in a lot of people's minds, you sort of say open, they think open source. And these are, for instance, some of the upstream community projects that here at Red Hat we're specifically involved with, that go into our cloud products and other parts of our portfolio in various ways. And obviously there's many other open source projects related to cloud out there. And certainly I think open source is an extremely important starting point in the context of cloud. And in fact, I'd argue many of the other aspects of openness I'll talk about probably not really possible without an open source component, because of things like reference implementations that open source makes possible. But I think nonetheless, it's an important point that open is just not necessarily the equivalent of open source, and that openness has a number of other aspects to it. One of these, and this frankly one of the reasons that at Red Hat we were particularly attracted to get involved with OpenStack, is having a viable and independent community associated with an open source project. If a single vendor has an open source project and it's they're the only ones working on it, I think that still has some value. It creates the possibility for others to get involved and to build on the innovation of that open source, but open source is most valuable when there is a viable and independent community that's associated with it that goes beyond one vendor or a few vendors. Open standards are a really key part of openness, and I think a lot of the time we see some of this in the cloud space, where you get this, well, this particular protocol or whatever is widely used, so that makes it kind of a de facto open standard. And yeah, there's some value to standards that the things that are widely used and accepted, even if they're not fully open. But I would again argue that if your business is betting on a particular standard, you have a lot more protection if it is truly an open standard. And in fact, over in Europe, we see some governments, most notably the UK perhaps, putting regulations in place to give preference to standards that don't have royalty requirements or that don't have licensing restrictions of any kind associated with them. There's this idea that's been promoted, something called free and reasonable access to standards, which some people have tried to promote as the equivalent to really open standards. And generally speaking, in Europe, the governments are shooting down that approach. Closely related to that is the freedom to use IP, because ultimately, if a standard, for example, is under the control of one particular entity, even if they're allowing its use and for now have reasonable royalty terms or reasonable pricing, you still don't have the ultimate freedom to use that IP. And who knows what happens down the road, as we've seen with many of the patent troll cases and so forth that have come out there. Having extensible and open API, I mean, this has been particularly prominent, perhaps in the consumer internet space. Some of the issues that you have when Twitter, for example, has sort of decided, well, you guys who were using our API in which you were building your business on it, and you thought what you were doing was fine, and you'd be able to keep doing that. Well, guess what? You can't do that any longer. And obviously, there have also been a lot of issues around Facebook. And in fact, this is sort of almost an endemic problem in the consumer internet space, where very popular services, at some level have gone a free pass for APIs that they've somewhat arbitrarily changed at times. But this can absolutely be an issue in enterprise computing or broader cloud usage as well, when we look at APIs for cloud providers that are limited to a specific platform, for example. And there's absolutely some trade-offs here between kind of value-add APIs and the idea of having these extensible open APIs. But as APIs become more and more central to the way we do computing, and, we used to write monolithic applications in an enterprise, or an independent software vendor would write this monolithic application, and it would pretty much be this self-contained kind of thing. In the web and sort of cloud space, increasingly we're building these applications that are almost these conglomerates of APIs from a whole bunch of different sources. And the problem we run into is, if these are not extensible and open, you can have this entire structure can fail if it loses access, for instance, to a particular data flow. And APIs in the web era is probably a topic for a whole other talk, but I think openness here is particularly important. And here we kind of get into the idea of hybrid, and ultimately we have an infrastructure that's going to be composed of many different things. in enterprising. I talked about extreme standardization in the world of cloud providers, and that kind of extreme standardization is typically not an option for most enterprise or government, large government organization or whatever deployments. Some of this is because of legacy. It's also because different infrastructures are better for different purposes. Again, you heard some of this discussed earlier. You may have heard some of this discussed earlier today in the context of these sort of traditional modes of applications where technologies like clustering, traditional Unix clustering, and very high reliability and very high performance, links between servers and the like are important. And then in other cases, hey, we really want to have this scale-out environment and do things as cheaply as possible and do redundancy at the software layer. And part of openness is being able to do that, being able to support that hybrid heterogeneous infrastructure. You know, and finally, a lot of this is really in service of having portability. A question came up also in one of the earlier sessions along the lines of, as I recall, what do you do if you have problems with a cloud provider, there's problems with reliability, you know, how do you deal with that? And a key part of how you deal with that is having that flexibility to move from one cloud provider to another, either to establish a redundant architecture across providers, or whether it's because, hey, this guy just isn't working out and we will move over here. So that is kind of collectively our view of openness at Red Hat. And you know, at some level, a lot of this is motherhood and apple pie, and you look at a particular solution or whatever, and you're never going to get, you know, perfect scores across all these dimensions. But you know, rather my intent with this is to sort of say, you know, these are some of the things that you all look at. Openness is not just about open source. Now, as we talk about how do we actually go about building an open hybrid cloud, the first step, you know, I kind of talked about legacy infrastructures a lot. And the first step really is, before we kind of do anything else, we really do want to simplify things, modernize things, even if it's not completely standardized things. And this means things like inventorying applications, moving maybe some of your legacy operating systems to Linux, modernizing some of your application infrastructure, virtualizing if you're not doing it, reducing a lot of gratuitous variability. And you know, again, this is a process as an operational play as much as a technology play, doing things on the operational side, like establishing standard operating environments in your systems management. So, you know, just because I'm talking here about hybrid being able to, as a way to paper over, abstract away some of this complexity, I certainly don't mean to leave you with the message that, oh, we can just leave things as complicated and unstructured as we want. It doesn't matter. I mean, it absolutely does matter. It's just that there's a recognition that you can't simplify things all the way, because there is going to still be some inherent complexity here. You might have things like virtualization sprawl, you know, a lot of VMs out there without a real centralized management structure for them. And you may still have some silos of management. You're going to still have some variability in your actual hardware and operating systems. And you may still have some manual provisioning processes. So we've simplified things, modernized things as much as we can, but then the idea is we really do all bring these under hybrid cloud management. So what does that mean? Essentially, it's bridging your sort of existing in-house IT. You may be adding some new standardized virtualized hardware. So this might mean putting in an IaaS. It might mean putting in some new virtualization clusters that are fairly standardized. It might mean making use of public clouds. And in many cases, it's going to be some combination of all of these. And then on top of that is kind of where the cloud thing comes in. So you have your operating systems, you have your enterprise middleware that can be deployed across those different environments. You have the actual hybrid cloud management. And what do I mean by hybrid cloud management? Well, it's functions like automating things. It's functions like having the ability to embed IT policies that, for example, might say, hey, here's this workload. This particular workload in this service catalog can't be deployed on a public cloud because this is an application that makes use of customer data, for example. It means having application lifecycle management. So this goes back to having standard operating environments, for example, and having tools to manage deployed virtual machines so that if there's drift or there's changes in configuration, alerts can be sent or those issues can be remediated. And the ultimate line here, so we saw that balancing act earlier, and ultimately what we're doing here is the way you're doing that balancing act is you're keeping enterprise admins in charge of policy and with the mechanisms to control those policies, while you have a user accessing a self-service catalog or using a platform as a service, perhaps, if they're a developer, with the same kind of ease of use they would get in a public cloud environment, but within whatever constraints enterprise IT is placing on them in order to adhere to policy. So, some of this has probably been a little bit abstract, particularly for this time in the day. So I'm just going to spend a few minutes here sort of going through some concrete examples of what I mean here. And I'm going to use Red Hat's portfolio as an example, but there's certainly other products from other vendors, at this show and out on the floor that would fit into some of these layers. And our philosophy here is very much that these are decomposable layers. So you can take the virtualization, you can take the infrastructure as a service, you can take the platform as a service, and you can roll in different pieces there, and from an architectural standpoint, there's nothing restricting you from doing that. So if we look at that infrastructure as a service layer, so down at kind of this bottom layer here, you've got enterprise virtualization, you've got physical servers, and you have infrastructure as a service. So essentially, cloud-style virtualization management with cloud services. And one of those, which is well represented here, is OpenStack. Mentioned earlier, great community associated with it, over 400 developers, and Red Hat's really gotten very involved, in part because it's such a vibrant community, and also there's this OpenStack Foundation, which has a really nice governance framework from our perspective. I deliberately didn't get into kind of a lot of the nitty-gritty of open source here, but one of the things that's also important from an open source perspective is having that community, having governance principles that lets people contribute, that doesn't put one person in charge. We've generally found that communities that have sort of a meritocracy type of structure tend to be most effective, and that seems to be working pretty well with OpenStack. And you consider OpenStack as sort of a modular framework with a number of different projects associated with it. So in that case, having that diverse community associated with OpenStack is really particularly valuable for that reason. That very bottom layer underneath the underneath the infrastructure. Some of you may have been at the panel earlier on about object-based file storage, and one of the points made there, which I certainly endorse, is that having that object-based file storage gives you this portability of storage across a diverse infrastructure. And Red Hat acquired a company called Gluster near the end of last year, and that's now Red Hat Storage. So it's this global namespace, software-only storage that can run in all these different clouds, whether it's on-premise or public clouds, very large scale, and that gives you your data portability across this broad environment. Because if you have SAN on-premise and you want to run the corresponding application in a public cloud, you can't move your SAN to Amazon. So having this software-only file storage, we think is going to become seen as something very important for hybrid cloud architectures. Another aspect of hybrid, which is important, is being able to have, in many cases, consistent run times across those. What do I mean by that? Well, the probably most familiar historical example of a consistent runtime is having an operating system. So you have applications, third-party applications, in-house applications developed for an operating system with the APIs and the updates and so forth, and have that operating system and its associated infrastructure, such as updates for security and other reasons, and having that be portable across different environments. And that container is therefore one good way of maintaining that portability of applications across different environments. So, again, this is sort of a continuing theme here. The storage is giving you data portability, the operating system or middleware give you application portability. In terms of the open hybrid cloud management itself, I had some words up in the cloud earlier. The particular offering we have there is called Cloud Forms. And again, the idea here is to bring together the IT control and governance and the end user self-service access, and really doing that balancing between the user sees something that's akin to the Amazon experience, while the admin is putting the policies in place, but where those applications can run, and is doing ongoing management of the application, and is creating the specific environments which the self-service user can access. So again, it could be an environment which is designed to be portable across this hybrid cloud. And finally, in the platform as a service space, OpenShift is our platform as a service, and it's openshift.redhat.com. Anyone can try it out. Developer previews. The developer version is free, and there's also a commercial supported version. And again, the architecture here is basically OpenStack doesn't care whether, it basically needs 1 to n operating system instances running under it, and then it does the auto scaling and the application multi-tenancy and so forth within that, and gives a developer access to essentially a code repository type of model of writing and pushing out applications, so they don't really need to worry about the operating system aspects of things. And again, our approach here is to have that platform as a service be able deployed on a public cloud. We have a hosted version of it today, and that's what the developer version is. But we also talk to a lot of customers, and they tell us, and there's a number of other companies here who as well who have had the same experience, that hosted is great, but a lot of companies are not willing to essentially to outsource their development, their main development platform to a public cloud. So, ultimately, I know this was a kind of a quick tour through a lot of material and a lot of different, admittedly related concepts, but ultimately, we at Red Hat see open hybrid cloud as being one of the key ways that you can manage the inherent complexity of enterprise IT, because while we're certainly in favor of standardization, and believe me, our Red Hat Enterprise Linux guys would be happy to talk to you about how great it is to standardize on Red Hat Enterprise Linux and other Red Hat products. But the reality is that our customers have heterogeneous environments, and they want to manage across that heterogeneous environment. And from a public versus on-premise or private cloud perspective, we really are absolutely seeing that as a trend, not necessarily with super dynamic, what's sometimes called cloud bursting, but definitely with the ability to use hosted utility type resources on maybe a project by project basis as there's spikes in demand. And Shrek says so. DreamWorks is a Red Hat customer, and they basically use very large grids to do their rendering. And obviously, an animation studio is a very project-oriented type of company. You have an animated film, and you have spikes in demand. And actually, DreamWorks has a very long history of exploring different ways to kind of access the kind of computing capacity they need when they need it, without necessarily having a lot of compute capacity sitting around idle a lot of the time. So we've been working with them since really doing grid computing, which some of you may remember when that was kind of a hot term, back with grid, and now they're looking at ways to kind of a more blended private-public type of model. So just leave you with a few things. I think you may have seen here, I mentioned some products, but I don't see cloud as a, hey, buy this product from me and you've got cloud. There's a lot of processes here, and there's a lot of thinking about your complete IT portfolio. Open hybrid cloud is an approach that I think lets you bring together some of that cloud, self-service, flexibility, speed, while not giving up the control that IT needs. There's a bunch of entry points here depending upon who you are. If you're a developer, platform as a service might be where you get started with cloud. If you're an enterprise looking at standardizing, sort of making a little internal cloud, maybe OpenStack is where you all go. If you want to do this hybrid cloud, start doing this hybrid cloud management, then something like our CloudForms product. If you just want to run some of your in-house workloads in a public cloud today, then you can buy Red Hat Enterprise Linux from Amazon by the hour. So that is all I have, and have a few minutes to take any questions. And my introducer is here now.
With apologies for not being the introducer, let's see who is going to ask the best question. It will not increase your chances of winning the raffle to meet and greet with the Temptations, but it will cheer me up. Come on. Gordon, what have you been saying to them for the last... He's covered, I know, about 1 million different things. So either he's covered them extremely articulately, which of course is possible.
It's possible.
Or this audience has fallen asleep. One question, I feel, coming on from my left, but nary a question. So they just really want to do that.
They're just shy.
They want to do the darn raffle. Ask them a question.
I can't blame them.
Ask them a question. Ask them a question.
Okay,
and
so...
I will fetch an answer for you. How
many of you have I convinced that you should be thinking about hybrid clouds? Okay.
Okay, now we choose one of them and ask them why. All the hands went down.
He is sneaky.
All the hands went down. But this gentleman's going to explain why Gordon's been so incredibly persuasive.
So actually, I have a question for you.
Okay.
What is hybrid cloud great for? What is hybrid cloud great for?
What is it great for? Okay, good. No, actually, I'll actually tell you first why that is a very good question, and then I'll answer it. I think we do see folks that I've heard the claim made that, hey, if something can run in a public cloud, it doesn't make any sense to run it in a private cloud because you remember the beginning of my presentation, public clouds, this massive utility, and of course it's cheaper and all that. Strictly from a cost perspective, first of all, the assumption that public cloud is necessarily cheaper has been generally debunked. And for understood workload levels, for kind of the baseline capacity for a lot of organizations, they feel they can run their computing less expensively internally and just use public cloud for unpredictable workloads. So I think that's part of the cost equation. I think the other broader part of the cost equation is that organizations who don't know how much capacity they're going to need. So they started out, in that case, they started out in a public cloud, and then once they kind of understood and got up to a certain level, then they bring part of it in-house. That's sort of how Zynga is actually a very good example of a company that's done the second thing.
So that leads to the question is, do you see the customer is actually, let's say, they are starting from public cloud or moving to private cloud once they are comfortable with it, or the other way? Or because it's just like driving a hybrid car, you have to maintain the oil and two things together. It's harder to maintain.
So I think basically the question is, isn't it more complicated to do hybrid? And I think that is a fair observation. I mean, I've been kind of pitching hybrid cloud, and we make a product that can manage hybrid cloud. I think there are cases below a certain scale level particularly where it may absolutely make sense to go all public or all private. And some companies like Netflix, for example, have just made a strategic decision that we just don't want to deal with servers. We're just going to go in a public cloud. But a lot of organizations are finding either they want that flexibility, or they have, the other thing is they have certain workloads that they have to run internally, but then they have other workloads that they can run and want to run in a public cloud, but they will keep those under kind of a consistent management umbrella rather than having the public cloud management and the private cloud management.
That seemed to answer the question. Over there, hang on.
So when we do move from public to private or private to public, when you have huge data like in petabytes or terabytes, how does that migration work?
Yeah, that's another actually very good question. I actually I wrote a piece not that long ago, kind of talking about the fact that the cloud are still real computers and real networks, and things like latency and bandwidth still very much exist. The answer is you need to architect your applications, and the fact is that by and large you tend to want to keep your data close to the applications running on it. So if you're dealing with multi-terabyte scale data, you may want to, you want the capacity to move in. That kind of relates into the object store discussion and all that. But you're not going to be willy-nilly moving multi-terabyte data sets kind of back and forth. Not to say you can't migrate where you don't want that portability, but your architecture should assume that that data wants to stay relatively at rest relative to the applications that are working on it.
Any more for any more? Here we come, you see? They've come alive, Gordon.
Might seem like too simple a question, but
No.
the difference between a public cloud and a private cloud, I mean, you keep using Amazon as an example. Is that what you...
Okay, so Amazon is a very good example of a public infrastructure as a service cloud. Mostly infrastructure as a service, but for our purposes here, as a public cloud. A private cloud is some form, is some degree, so a private cloud is a set of computing resources being operated in a cloud type operating model on resources that are under your control. And that may be an on-premise data center, it may be dedicated resources at a hoster of some sort. So,
a rack space would be...
Rackspace has a number of different types of hosting services. Rackspace actually offers both a public cloud, and they also offer dedicated hosting. So you could actually have both a private and a public cloud on Rackspace. The real difference is on a public cloud is a multi-tenant model in that you're sharing the resources with people who you don't necessarily know who those people are. Whereas in a private cloud model, whether or not it's in your data center or with someone else, you own the whole thing, or you control the whole thing.
Make sense? A final question. I'm trying to watch it. No final questions. That means that was the final question. Let's then please thank Gordon Haff, Evangelist at Red Hat, for a splendid session. And they're not going to be moving from their seats